oscillation and periodic motion. Any object in the world can oscillate backward and forward, upward and downward, here and there. Oscillation is the motion of an object about its equilibrium position. The motion of an object about its equilibrium position is said to be oscillation. For example, if we take simple pendulum oscillates here and there about its equilibrium position. This is equilibrium position which is found at the center of the oscillation. So about this equilibrium, about the equilibrium position, this pendulum oscillates here and there, here and there. Periodic motion. Periodic motion is the motion that repeats itself at a regular interval of time. The type of motion that repeats itself at regular or equal interval of time is said to be periodic motion. Oscillation can repeat itself, but it may be at regular interval of time or not. It may be dampened due to certain external influence. But in periodic motion, the type of motion that repeats itself at equal interval of time is periodic motion. For example, if there is no air resistance or external factor that affects the motion of the simple pendulum is a periodic motion, can perform periodic motion. Equally, it oscillates here and there. This is axis of rotation. I mean that equilibrium position. At equilibrium position, x or displacement is equals to 0. Oscillates there and returns back to the equilibrium position and to the left and returns back. At this time, there is a force that opposes the motion of the simple pendulum. When the simple pendulum moves up to the right, there is a force that acts to the left towards the equilibrium position. That is said to be restoring force. Due to restoring force, oscillation is formed. Restoring force is the cause of oscillation. Because while the pendulum is moving to the right, restoring force acts to the left towards the equilibrium position. While the pendulum moving to the left, restoring force is towards the equilibrium position, and it returns due to restoring force. It restores the motion. So, due to restoring force, oscillatory motion is formed. Spring mass system. Look, string mass system moves down, up, extension x. This is the equilibrium position. Moving down, and a certain extension is formed and compressed up. So, this is the equilibrium position. When the spring is moving down, the restoring force is up. Restoring force is up when the spring is moving down. Now, restoring force is directly proportional to the negative of displacement. This negative sign shows that restoring force and displacement or extension of the spring are in the opposite direction. Here, from this simple pendulum, if this is angle theta, restoring force acts toward the left along this line while the pendulum is moving up. Therefore, restoring force for simple pendulum is equals to mg times sine of theta, where theta is this angle. Mg sine theta, this is restoring force for simple pendulum. Restoring force for spring mass system from this expression, it is possible to say restoring force for spring mass system is equals to minus k times x. This is Hooke's law. K is the spring constant, X is extension of the spring, restoring force is equals to minus K times X, minus K times X. There are very important terms to describe oscillatory motion, just like amplitude. Amplitude is the maximum displacement that reached by oscillating body. For example, if this is a simple pendulum, the maximum displacement reached by this pendulum is said to be amplitude. Amplitude is the maximum displacement. Amplitude can be negative or positive, or it can be amplitude can be negative or positive. Maximum displacement to the right, let's say 3 cm, to the left minus 3 cm. It can be negative or positive. Repeat it so that the graph is sinusoidal. It looks like this. Moving up, the return down, then back. One cycle is completed here. Up, positive, let's say, down, negative. Here, if this is minus 3, this is positive 3. Positive 3. This is amplitude. This is also amplitude. This is also amplitude. Another important term, frequency. Let's say period. Period is the time used for one cycle. The time used for one cycle. For example, if the simple pendulum starts from this point and moving up and returns back to the left and returns back to the equilibrium position, one cycle is completed here. So, starts from this point, moving up, maximum displacement, returns back to here, 0 for X or equilibrium position, and moving up. One cycle is completed. Therefore, the time used for one cycle is period. Frequency is the number of cycle. Amplitude, frequency, period. They are important terms used to describe oscillatory motion.